Dear students, today we see about the important functional groups present in the IR spectroscopy. When we plot IR spectrum we get IR spectrum from the IR characterizations. So what to look in the IR spectrum and how the important functional groups are detected from this IR spectrum. So today we see. So this we have already seen that, or the broadly speaking, the IR region is divided into the two main regions. Considering this, the functional group region, it is further subdivided into the several regions and for more time. Only three of these are considered now. The fourth region falls in the fingerprint region, where the carbon oxygen stretching bands of the alcohols, phenols, carboxylic esters, and some carbon nitrogen stretching bands of the amines and amides can be identified. For the quick overall assessment of the spectrum of detection of the functional group, so we have to consider the characteristics regions of the functional groups. Considering the highest energy region, that is hydrogen region, it falls between the 3600 to the 2700 centimeter inverse. It is generally seen that more polar bonds are normally stronger than less polar bonds, and thus absorb at higher frequencies. Carbon hydrogen bond, that is 2950 centimeter inverse, it is absorbed frequency. Nitrogen attached with hydrogen, this is a single bond, it is absorbed between 3300 centimeter inverse, and oxygen H bond absorbs near about the 3600 centimeter inverse. Not hydrogen bonded, so it is not hydrogen bonded. The bond strength increases in order. There is carbon hydrogen, it is a first, then nitrogen attached with hydrogen, then oxygen attached with hydrogen. The carbon H bond strength varies slightly because the hybridization of the carbon atom increases in the order. So these are the various frequencies of the functional groups attached to the region and the strength of the bond. It directly affects the absorption frequency of IR spectrum. If we see carbon-carbon triple bond, carbon-carbon, carbon-nitrogen triple bond, carbon oxygen double bonds, or the carbon-nitrogen single bonds. If we require the more energy to break the bonds, then this bond also requires the more absorption IR spectroscopic energy to give the IR spectrum. So if we see the carbon nitrogen bond, carbon hydrogen bond, that is carbon hydrogen bond in the sp2 hybridizations or the sp2 hybridizations or the sp hybridization. So we required, or the absorption range is between the 3400 to the 2600 centimeter inverse, and it is decreases to the carbon triple bond. It is near about the 2200 to the 2000. Then carbon double bonds or the carbon oxygen double bonds, it's near about the between 1800 to the 1600. Then the single bond or the fingerprint region, it is near about the 1200 to the 600. So if the bond strength is more, and then we absorption energy is the more. So absorption energy is more. So by identifying these various spectras or the bands in the air spectrums, we can analyze the different types of the functional groups are the present in our organic compound or the inorganic material or in the our IR spectrum.